Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. Welcome, everyone. Today we have with us Roman Elizarov. Did I say that right? Close?
That's fine.
Close
yeah,
enough.
That's close enough. Yeah.
Who is the language designer on Kotlin. And so super great to have you. Bruce and I have been doing a lot with Kotlin. You wrote the Atomic Kotlin book, and now in my job, I get to do a lot more Kotlin. And so great to have you on to chat about Kotlin. Thanks for joining us.
Mm-hmm.
And nice to meet you.
You weren't initially the lead language designer. Somebody else was doing it, right?
No, Andrew Brislav was initially doing, but I was involved actually from a bit from
Right.
the very first days when Language was born in 2010. I didn't work even at JetBrains back then, but I was invited as an external reviewer for the initial language design, so I had a chance to participate at the birth of the language, and then did my own things for several years.
And you did a lot with coroutines. Did you create coroutines, or what was your relationship there?
When I joined Kotlin team shortly after Kotlin 1.0, there was already a prototype for coroutines implementation that was planned for Kotlin 1.1. When I joined, I started participating in language design and still which was led by Andrew Beslov back then. And one day we were discussing some corner cases of coroutines design, and I volunteered to take a closer look at coroutines to participate in that. And it's mostly because of my prior experience working with server-side code and having solved, in practice, various scalability problems that actually would have helped me a lot if I had coroutines back then when I was programming.
Were you mostly Java server side before?
Yeah, I was mostly Java server-side developer and core libraries. So I did big financial systems in Java, both from architecture, design, implementation, as well as maintaining various libraries at the core of those systems.
But you didn't go actors in that world, because a lot of those financial systems, I think, went actors.
We didn't. We did lots of homegrown things that are conceptually close to the way actors work, and again, we never been big on frameworks historically, because again, usually in actor systems you have to rely on a big framework and trust it. And when we started with big frameworks with EGB, back in 2000s.
Yeah,
it was all the rage. But then we kind of became framework low. We gradually started to rely on our own small focused core libraries and read less on all-encompassing frameworks that solve everything for you. And so the same story with actors. We solved problems we faced with utilities we needed, but never embraced any big framework.
So as you were designing coroutines, was part of the kind of motivation or thinking based around, if I would have had this when I was working on those financial systems, it would have made my life easier?
That's exactly that, because initial prototype, it was inspired by C#, and that's not a secret. It's still the C# influence is quoted in the design document as the main one. That was initial. It was a bit Kotlinized, turned a bit on Kotlin style by adding more flexibility and operators into the design, but still it was initially heavy C# based, and which was and it was hard to solve the problem that I would have found useful solving in my life back then. So I was tweaking this design to make sure it's as clean, as simple as possible to solve not just UI style problems, but also server side, and to basically make it as encompassing as possible.
That seems like hard to design something that has such a broad number of use cases that it could be used for, because server-side needs are very different from UI needs, but somehow I think coroutines have found that sweet spot that it's great for both ends of the spectrum.
Yeah, when you think about it, it's not that designing something all-encompassing is hard. I mean, designs often fall into this trap because of trying to overgeneralize. They're trying to create this general thing why this is a trap? Because by doing very general thing, you usually sacrifice performance and toolability, ability for tools. Like you can have like really generic solution, like take Lisp. You could do anything in Lisp, but then no tool like in IDE will be able to work with your code because your code has become too general. And so the problem always in design is finding this balance. You want it to be general to solve the problem you have on the table, but not too general as to lose performance or to make tools like again, take the Lisp board. You can solve every problem with macros. Like, why would you need coroutines? Let's set macros to the language, implement coroutines in the macros. Easy. But then you have macros in the language, and you threw all your smart tooling out of the window because it won't be able to see through your macros.
That's right. Yeah. We talked to Martin Odersky about exactly that a few weeks ago, and how they've really backed away from general macros because of all the downsides to that very general solution.
Mm-hmm. So what was your what was your philosophy when you were creating the coroutine system? What problem were you trying to solve that maybe wasn't solved? Or maybe I suppose a better question is, like, other than C#, were you taking inspiration from like Go?
The other source was definitely Go. I mean, basically after C# the second. So what I wanted to, so having C# inspired design at the start, that's like async await, and in the prototype it was like async await. The keywords were async await basically, and stuff like that. The idea was that okay, now we have C# like things, but now we want a Go-like ability to write code like in Go, where you can simply compose functions, when you can loop, when you can do without blowing up the language. Because if you look at the way C#, if you look at C# without coroutines and look how coroutines add to it, they not just have async await, they have a wait for loops, they have await vars. Like there's a lot of complexities. Like this await starts to creep into all corners of the language, complicating all the constructs in the language, because now we want to support all of the things. So what I wanted to achieve is I wanted minimal mechanics in the language, minimal changes, but then you can just simply write code and use coroutines whenever you want. And that's why we ended up having just suspending functions. And that's why we the scariest design decision was not to have any kind of weight on the call side, like it's in C#. And we chose that we do it only in the IDE show, whereas your suspension points are. That was hard, but we made it because of Go, because by that time we designed Go was becoming popular. And we read, lots of testimonies of people who programmed in Go were happy about it without having to write the weight all the time. And that's convinced us it's okay not to have to write a wait all the time.
Yeah. Like, why should the developer have to tell the compiler that information? It's like, no, let the compiler figure it out. The compiler knows what a suspend function is. Like, don't make the developer have to think about that.
See, some people still think it has to be in the source. Some people still think that's information that you're waiting is so critical, it has to be expressed in the source. There's no look at Swift. They added coroutines recently. Still, they chose to write a wait on every call site consciously because they thought that's critical piece of information has to be in the source. Now, we've looked at it a different way. We looked, and it's actually reminiscent in the way we view other features in Kotlin. So the way we view it is when developer writes the code, they have to first and foremost think about the business logic. So the source, what they write in the source, has to reflect the business problem they're solving. And everything else in Kotlin design we consider to be boilerplate that we want to reduce. We don't want to see all the other stuff that's not directly related to the business problem. So for us, this fact that you're suspending from time is a secondary information that's not directly relevant to the business process you're coding.
Yeah, this is one of the things that I've liked a lot about Kotlin is the removal of things that you don't absolutely need. And it's like,
Well, and have no value.
well, right.
Like saying await,
Mm-hmm.
there's no value to, like, as you're reading through the code. It actually is distracting.
It's confusing.
Yeah.
It's like, why do I have to
It's
do
like,
this?
I don't care.
Yeah.
I don't care that it's
Right.
that it's asynchronous.
And knowing, now that I'm beginning to understand, that is just decoration that the compiler can, if the compiler can figure something out, I want it to do it for me.
Yeah.
And so, keep it.
I mean, type inference is another great example of this. It's like, why should I have to tell the compiler this information?
Right.
Like, just is unnecessary most of the time.
Yeah. It's very frustrating to me when I see that in other languages.
Yeah, it's like, and we've talked about this on many episodes. Like,
Yes.
Are we serving the compiler, or is the compiler serving us?
Right. Yeah, it's the whole point of a higher level language is that you don't have to do that low level bookkeeping.
Yeah.
Which is one of the things that I really enjoyed about Kotlin was how it lifted tried and tested features from other languages rather than just saying, oh, we're brilliant, we'll invent everything from scratch and it'll be awesome, like some languages I could mention.
I mean, if you are working at a university and have a bunch of postdoc students who want to do research, that's maybe a great way to handle language design,
I guess. But it's, I just really respected the idea that, well, let's look and see what works really well in practice in these other languages. And I'm amazed that, with all the languages that I'm seeing, I'm amazed that you guys were able to pull that off, because it seems like there's a lot of, no, let's invent it ourselves, we're awesome attitudes.
Yeah, it's one of the conscious things in Kotlin design, because Kotlin is pragmatic, meaning that it's for industrial use for regular developers, and because it has to be easy to learn, and easy to learn means it has to use knowledge that people already acquired from other languages, and this kind of limits us in our creativity. But that's a good limit to have. Like, we consciously have to stop ourselves from inventing complicated things and have to try to see what's out there, what's already people know, what people have learned to reason about, and we use that in Kotlin.
Yeah, one of the things that I noticed is that you did almost no invention, except in a few places, like the lambda with receiver, which I prefer to call extension lambda because it fits my mental model better. And that seemed like something where you said, oh, we really need this.
But it's not, again, invention completely new. It was like the syntax was inspired by Groovy, and most of the behavior was inspired. What's new is how it was, kind of tweaked into the static type system so that it behaves in predictable way. The problem with Groovy lambdas, they're also great for this self stuff, but they have this dynamic and complicated behavior with this. In Kotlin, it's more predictable and for static language. So it's again not something we just invent. It's something, again, we take and adapt to the style and needs of Kotlin.
Can you think of any features that were kind of like invented in Kotlin and don't have like a heavy prior art side of them?
Not really. Most of the features in Kotlin and in many other languages are mashups of features you would find. Even coroutines, inspired by C#, Go. By Lisp, the way you work with continuations. But still, it's mashup of things that has been known before and has found to be useful in other circumstances. They could be combined in novel ways, like in lambdas. Static support for those receivers is a novel thing. Syntax, a bit novel. But again, when we invent syntax, sometimes we have to do a novel syntax, but again, it can't be 100% novel. Like, we can't take a character and we invent it for some use that never been seen, because nobody will then understand the language by reading it. Like plus has to mean addition, like minus has to mean subtraction. Like there's only so much we can do, and only so much we can be creative, because otherwise we'll just ruin the language. We'll make it impossible for other developers who are new to Kotlin to read the code.
So there is a new feature that we've been kind of puzzling over, the what's it called?
Context receivers.
Context receivers, and we were thinking that it was kind of like
type
classes, but it doesn't seem to be fitting that way. Can you give us some perspective on context receivers?
It's actually very much type class. It's actually the people, the use cases for this feature, they come from a variety of places, but they very much also come from the use cases that people familiar with type classes have, and it's very much inspired by Scala's implicits with given a using in the Scala 3.3. It's a different feature though, because again, there's no way we can take like a Scala feature and adapt it to Kotlin because of very different language style. And unfortunately, there's this feature. There's little precedent in this kind of a feature in other languages, and that's where we'll have to do some invention. Simply because the very concept of implicit receiver is very Kotlin specific, but it's very well understood by Kotlin developers, because in Kotlin TSLs and Kotlin scope functions, you have this implicit receivers because of this, lambda Swiss receivers so much often. And when even people who don't have prior Scala experience, who don't know what type classes are, they start running into limitations. They start running into DSLs they want to create, but can't, because you can have only a single implicit receiver. So there's, on one side, there's been always this request, please give us ability to have multiple implicit receivers, because there is a litany of use cases. People run into this single receiver limitation in various contexts. We have this huge laundry list of cases where people run into it. And on the other side, there are people coming from Scala from actually dependencies injection kind of style. They want something like temp classes, or something you can call it dependency, where they want some contextual information to be injected in their code without having to explicitly pass it. And I know this becomes really scary territory, because there's a saying that developers will do any atrocity just for not having to pass function parameters explicitly. And of course, there's always better to pass things explicitly, always better, your code more readable. But then it became
it's unwieldy at some point.
It was unwieldy at some point, right? Because if there is a thing like log, for example, or something, or some kind of context that is really kind of all throughout your application, having to always pass it explicitly will make your code unreadable. And that's what context receiver designed to solve, so you don't have to pass explicit. But again, this is really the reason why we're carefully approaching this feature, and we're not going all this Scala way, because this feature has really high abuse potential. Because by passing things, so on one side, it has potential to make code cleaner by removing repetition of having to explicit. But on the one side, you can abuse it, and instead of explicitly passing things, you can start passing them implicitly, making your code unreadable. So there's a complicated balance here, and not just so it's not only that we have to add this feature to the language, we also have to figure out how to properly use it. And so one thing we're doing right now, we're starting to use it in our own code to gain this experience. So this experience can help us into the feature design, so we can not just release the feature, but also give some guidance to people where it's okay to use, where they should consider not using it.
Yeah.
Are you mostly thinking of it as a way to get rid of dependency injection, or?
It's not really getting rid of dependency. It's mostly, again, the reason we called it context receivers, because it's mostly, again, about passing information that comes from context to functions. And when you say dependency injection, you usually write your code in classes. Like you have a class and you choose dependencies. But Kotlin is more functional. In Kotlin, you always write code in functions. But functions are not, they're usually often top level. They don't have class
There's no
to
member
inject it.
function. There's no member
There's
member
no place
properties.
to inject dependency to, and
Yeah.
so that context receiver, they help you here.
Mm-hmm.
Yeah,
Mm-hmm.
that makes sense.
What sort of, I mean, we've talked to other people who've built functional systems on top of the JVM, and it's always sort of a battle because the JVM wasn't designed to support, immutability and things. What's your vision for Kotlin going forward in the kinds of things that you might do to support functional programming better?
Immutability is the next big frontier for us. That's we've published last year this big kind of, it's not design documents, just notes on our way forward on value types and all the immutability things, and we're really using this as our next big thing to do, because we believe as computers become more powerful, as we write bigger code, immutability is the way to go. It lets us write more scalable code that's safer, that's easier to debug, and we can afford it. Like, yes, it's slower, but I mean, we have the resources to do it. And so we actually want better immutability support in Kotlin, despite the fact that it's not natively supported JVM. That's not something that will stop us. Of course, we'd love to see more support, like for value types, for example, in JVM, and maybe it's the project Valhalla, maybe it's coming one day, but it's not something that's stopping us from doing it. We believe there are many use cases for more working with immutability already. Even if you are having to pay high price and performance for it, there are lots of people who are willing to pay this price as long as their code. So what many people get stopped, first of all, right? I'm looking, we're constantly doing language, just looking at what kind of code people write in this class. And what we're seeing, even though right now lots of people prefer to use immutability, even though it's even syntactically clunky in some cases. Like when you have a deep immutable structure, it's not convenient to modify it in Kotlin. You have to do this copy calls, etc. Despite of that, people still do immutability. So they're willing to pay the price of more verbose syntax. They're willing to pay the price of slow performance just because immutability gives them safer. And what we're planning to do, we're planning to reduce their costs. We're planning to give them better syntax. Let it be as slow as before, but even better syntax would help those people. And then if we are able, if our runtime, the JVM supports, gives us ability to get better performance, that's great. But if not, that's just giving them better syntax is already great.
Yeah. Yeah, and I think one of the arguments that Bruce and I were debating recently was that I think the general position is that immutability is slower, but I've seen that in a lot of systems, it tends in reality not to be, because what happens with mutable systems is that you end up just taking like this huge like synchronized block and like wrapping a bunch of mutable stuff in a synchronized block, making it single threaded anyways. And so like you're, in a lot of cases, you're not actually in reality getting the performance from mutable things. Like another example I was thinking about was the JVM date time formatter. Turns out it's not thread safe, which is not expressed through anything in the API, which is a whole nother thing we could talk about. But there, I think that's an example where you're like, oh, I can just reuse this one instance and call the date time formatter repeatedly and not have to recreate a date time formatter. And then all of a sudden, in reality, you realize because it's not thread safe, you either have to wrap it in a synchronized block or recreate a new one every single time. So it's like, okay, mutability actually like didn't actually give us any value on performance when it came to how it's actually used.
Yeah, it's really depends on your domain, and choosing the right data structure for your task is complicated. People spend years just studying data structure design. And take another example, even without working with big text files. Like the naive solution is to just use big mutable structure with all the strings, but then how do you insert a string in the middle? You'll have to shape shift all these gigabytes of data, and that's where using a persistent immutable data structure is just gives you better performance at scale at when you're editing big text documents.
Yep.
And there are many examples like that where indeed immutable structures fit better. But the converse is also true. Like if you simply take a typical application that doesn't work with lots of data and simply replace all its mutable lists and maps with mutable ones, you'll get your performance will suffer. Again, it's not. But again, suffer. But okay, like if your application didn't work with lots of data, why do you care about performance? Then
Right.
maybe you should have started with immutable data in the first place, just to be safer on the safer side of not accidentally,
A lot of
mutating
times,
some
going
shared data
mutable
structure.
is like a premature optimization.
Right. And if your performance is if your program's running faster but it's not correct, is that what
Is that worth it?
so the topic, the date time formatter and a number of other libraries in Java where you discover later that you go, oh, this particular library isn't type safe, or that one
Thread safe.
isn't thread safe. And so how does Kotlin land? I mean, is there a way to know whether all of the Kotlin libraries are or not type safe, or is it on a case by case basis? Sorry, thread safe, case by case basis, like it is in Java.
So in Kotlin, it's really straightforward. If you look at the Kotlin standard library and many other libraries, standard libraries we do run Kotlin, they are immutable first. Like by default, everything you work with is immutable. Like take lists, maps in Kotlin. Like by default, unless you explicitly ask for it, they're all immutable. Like they're like list, you can mutate it. Map, you can mutate it. Like you can transform it, filter, do another list or map out of it, but by default, it's the same with datetime that we're developing right now. The same with coroutines. Like by default, we're placing you on the safe side, and we're if you
I
want
can't think of a
something mutable-
Kotlin standard library API that isn't thread safe that I've run into.
Yeah.
But
Exactly.
Maybe it
It's all
exists
because it's
somewhere.
all immutable, and if it's immutable, it's very safe because you can't mutate it, so you can have any data races. And in Kotlin, you always have to be explicit if you want something mutable. Like in Kotlin, even its variables, while and var, like you write while by default, and only if you want to mutate it, you ask for it, you say var. Like if you take a list, it's immutable. If you want to mutate it, you have to be explicit about it. You have to say, I want a mutable list. And now, again, by default, if you ask for something mutable, that means it's not thread safe by default. We don't have like thread safe mutable data structures because again, it's usually that's the wrong design because usually you need something more complicated and you'd rather we give you if you want we'll nudge you to use immutable things that's safe to share, and when you want to mutate you have to be explicit, but then it's your responsibility to make sure you don't mutate it from concurrently from different threads.
Yeah, and it seems like, I mean, I guess that was really surprising for me in Java was it's like, oh, there's this other thing about a library you're using, which you have to go and investigate if you're going to be using it with threads to find out whether it's, and there was no, tag or anything on it that said, warning, this is not thread safe. And so it just complicated things so much.
But it's again, unfortunately, that's Java legacy. That stems from. I mean, every language has this. If you look at the Java 1.0, I mean, it used to be the case where the way you build strings or way you work with vectors, the list, it was called vector, and it was synchronized. And we now know that's the very wrong thing to do. And Java also corrected all that by introducing modern collection library later on, but it's kind of this legacy still lives with Java.
I had a conversation yesterday with someone who was asking about they're in their code they were using a var, and then they were doing a null check, and then of course, like, because it was a var, it's like, no, like we can't verify that we do the smart casting to verify that this is still not null. And so they were asking about that, and it made me think, like, I need to do like an office hours that is the var to val workshop, where anyone that is using a var, they can come to my office hours, and I'm going to help you get rid of that var. Just because I think, like, when I started writing Scala, I was writing everything like I wrote in Java with lots of mutability, and now I pretty much never write a mutable thing. Like,
you cross this line where you become fanatical about.
Yeah.
You're going, no, I don't want to mess with that.
It's
just
like, it
make
feels
it a val.
so dirty to write var.
It does. But that actually brings up an interesting topic, which, like, while we were writing the book, early on, to produce immutability, there was a two-dimensional array that needed to be initialized. And Svetlana knew how, or found out how, to write this rather complicated piece of code in order to initialize it in an immutable way. And it was hard to track. And then at some point later, she said, no, we shouldn't do this. We should use a builder instead, and it's much easier to understand. Now, James has a lot of trouble with builders, just from a philosophical.
I've been hurt by builders.
So, and it's like, and then, in functional programming, you see, like, there are points where they say, okay, well, this is actually mutating, but it's not visible to anybody, so it's okay. And I think hide the mutation. I feel like that's what's happening inside of builders, is that the mutation is not visible, and so it's okay. But
yeah, I mean, so part of my challenge with builders, I think, really stems from the way that they're used in Java, where you only find out that you're in an invalid state at runtime when you call that .build method. And in Kotlin, I don't have as bad of a experience with Kotlin builders, because generally with nullability and default parameters, generally the APIs that have been built with Kotlin builders are giving you the information at compile time around what a valid state for the construction is.
Okay.
Still, the mutability does hurt a bit, but it's like, let's just use constructors. But I understand there's sometimes some syntax overhead to that approach.
What's your thinking about this?
It mostly depends. My thinking, I think it mostly depends on education. If you look at how we teach kids to program right now in our world, is that we teach kids to program in imperative way. We use Scratch, we use Python, and we teach them imperative programming first. And only then, after that's how all the kids nowadays learn to program. Only then, somewhere in university, they might get introduced to functional programming, and will get, understanding of how to do functional transformation, etc. But still, some people will get it, some don't. And for Kotlin, for example, it has to be pragmatic. It has to be accessible to millions of developers in this world. Some of them, and many of them, don't have any higher education. Many of them were never exposed to the course on functional programming. They might have learned, Scratch and Python, and then went to Kotlin. And they have to be able to code. So we have to strike this balance where we give them and we nudge them into these functional tools, but we also give them fallback, because for many people, especially if you're faced with a complex task, and I've seen this multiple times, and I know how to express it using group by, filter, map, and other, but some people don't. It doesn't come naturally for them, and so we have to give them tools to get their problem solved in the way it's convenient for them, so they can, if they feel if it's easier for them to write in imperative style, then let them run imperative style. And that's why we give builders, because they kind of a compromise. You can use imperative style inside, but then we kind of contain this imperative mutability so you can express it the way you like without polluting all your code with mutable structures, because at the end the builder returns a mutable thing that you can work further in your code.
Well, it makes me wonder if Svetlana didn't, and I don't remember who wrote this, but maybe she ended up going to you, and you, because when I saw the code, I go, okay, I can fight my way through and understand this, but I can't imagine writing it myself, going through the steps to come up with this, as a native way to think about it. And so, whereas the builder does, at least it's readable.
Svetlana is good at that. She's been teaching people to use Kotlin standard library and the the functional way of thinking about transformation for quite a long time. She can. She knows her thing well.
Okay. It seems like it's a maybe core philosophy of Kotlin is to make sure that people can go on a journey from where they are to where they may the happy path that's down the road, and making that a journey that they can take. Whereas I love Scala, but I think that Scala, and especially the way that I write a lot of Scala now, it is not at all accessible to the Java programmer that I used to be.
Yeah,
there's not a journey there.
And you have to understand that I also do competitive programming, and that's where, you don't often run into this kind of problems in business practice, but in competitive programming, you do run into problems where the algorithm has to be fundamentally mutable for performance reasons. Like you see, there are lots of problems in competitive programming that either some of them cannot be solved with immutable at all for performance reasons, and it's not like constant factor of performance, but but asymptotic performance suffers when you try to solve it with immutable data structures. Or there are problems where you can write, an immutable transformation to get problem done, but it doesn't look natural at all. For many problems, it's way more natural to model them. Natural in the sense that your code reflects your thinking. That's what I call natural. Like if you're given a problem that is explained to you in imperative term, like the problem statement says, you have a square field and you do this, this, and that things. Like it's more natural to translate the problems. Like the more directly you can translate your problem statement into code, the better. So and that's kind of a balance we try to strike in Kotlin. Because if you look at how business problems usually formulated, they're usually imperative at large. Like they give you steps, like do this, that, and this. But every step is usually declarative. Like if you take a business problem, that the step would be declarative: filter out these elements, or or do this transformation. But by combining the imperative and functional programming, is called the programmatic way, will let you transform your business problem statement into the code as directly as possible, just like it was formulated. So you can do big imperative step and be declarative or functional at each step.
Yeah. Yeah, I guess I've experienced that where I'm working on a particular problem that essentially is the problem is an imperative problem, or is defined imperatively, and being my immutable functional programming, who I am, I then have to map that to these concepts that are not at all related to the business problem. And so I'm like, okay, I'm going to need an applicative here, and I'm going to need to do a traverse here. And that's not how the problem was defined. And so I have to do this translation. And yeah, it's fun, but maybe not the most ideal way to solve business problems.
It might be fun if you're working this alone, but in business and industry, we often use in the team. So it's not just you who have to go through this mapping when you write the code. It's also the person who reviews and maintains your code. Then they have to take the problem descriptions and again perform this mapping. Right. And mapping is usually not one-to-one. So the other person may have a different way to map it, and they will have a hard time understanding how you mapped it. So again, And for Kotlin, this is really big philosophical principle in language design, that you have to be able to transform business problem into code as directly as possible.
Huh. Yeah, that's cool.
Okay, I have a question, more specific about. I've been sort of puzzling over what happens in the code with concurrency when I say suspend. It generates different code, right? When I put the okay, I'm guessing it's building some kind of scope where the continuations are passed. Is that something like that?
Yeah, it's building a state machine. Basically, it's taking your suspension points and it's building a state machine where there's transition between those suspension points. And when you suspend, it snapshots your state to the state machine, remembers which state it's at, and then when it has to resume, and then resumes from this place. And that's not something we invented just to make sure like the C# compiler works in the same way JavaScript runtimes work. It's like been there for ages.
Most coroutine systems work that way, right?
Not, I can't say most. I mean, there are different implementation techniques. Like Go works in different way. Go just switches stacks. Or, for example, the upcoming support for coroutines in GVM, the project Loom, they use a different technique, yet another different thing. They copy stack to off storage and suspension. So, I mean, there are, but I mean, those three approaches are probably enumerated, like state machines like we do, Go approach, and this verse, there's probably the three major ones.
Well, and it seems like any suspension is, capture all of the necessary information so that later it can be restored. I mean, even when you look at the way a thread context switch happens, it says, well, we'll just capture everything and store it away. And it seems to me like the difference between a thread and a coroutine is a thread says, you can switch anywhere. And a coroutine says you can only switch where you've told me you're going to switch. And the cost for switching anywhere is like, well, the benefit isn't that great. And to reduce that for a coroutine switch to just the minimum amount that we need is a much better trade-off than just being able to switch anywhere. Am I getting something here?
You are, but the picture is actually a very clear one. Even like computer science researchers can agree on what exactly coroutines and how to classify in modern world, because there's so many different approaches that blur the lines with what coroutines. For example, if you look at Go, what you can clearly say that Go language has built-in support for coroutines, yet you can suspend at any point and doesn't have to mark them in advance. Or things like that. So I mean, there's a real blurry picture of what coroutines are. But what people would agree though is the coroutines are necessary lightweight threads. That's something common to all coroutines applications. But it's basically the reason why people start doing coroutines in their runtime language in the first place, because threads are expensive. They keep a big stack and they cost a lot in operating system. They're expensive to switch from one thread to another, and people run into scalability bottlenecks or just run out of resources with threads, and that's where they start thinking, oh yeah, we have to do something else. And there's something, whenever they do something else, they call it coroutines, but again, implementation techniques and approaches differ a lot across languages and runtimes.
Oh, well, that's actually very helpful.
Since you brought up Loom, what are you thinking about for the relationship of Loom and Kotlin and coroutines?
Loom, it's when Loom releases, it's going to be a really complementary relationship, because Loom and Kotlin coroutines are optimized in their implementation for different use cases, while they can support variety use cases. But again, what you optimize for is different. So Kotlin coroutines perform best for things like UI, where you have lots of fine-grained, lots of their small things like event handlers, processing pipelines. That's where Kotlin coroutines excel. Where Loom excels and what it's optimized for, it's optimized for like I/O, where you process chunks of data and then occasionally suspend because not enough data, because either you try to send data and socket is full, or you have not received a packet of data yet, but your packets are big. Like you receive this big chunk of data, process and suspend it to the next big chunk of data. That's where Loom excels. And because of this complementary relationship, we can, when Loom's out, what we're planning to do, we actually plan to, so we have in Kotlin routines, we have this dispatchers IO, which you have to use if you're doing any IO things like read files, and that's where we
like mark it as being something that needs to have a different pool, essentially, like running a different pool.
Exactly. And right now we have to use heavyweight threads in this pool because we know that you're going to physically block it. So we need, and those threads are expensive. So you do a lot of this heavy IO, the block, you're using those expensive threads. And with Loom, we'll be able to do this instead of using heavy threads. We'll be able to use virtual threads, as they call them, in Loom. Nice. Yeah. And that will make those kinds of applications even less resource consuming.
Yeah. I was thinking about this week how so much of what we've done in programming, maybe forever, is just making it easier to efficiently manage resources. And there's just this constant evolution of not putting so much onus on the developer to manage resources well, moving that down a layer so that they don't have to deal with it, but then constantly making that resource management more efficient. And non-blocking is part of that. Garbage collectors are part of that. Like, there's just, I don't know. It's just
well, the developer is a resource as well.
That's exactly. That's good observation. I mean, we're also piloting abstractions on abstractions, and the reason for that is we want to, like, the most precious resource we have now, the developer time. I mean, the hardware is becoming cheap and becoming cheaper every day. I mean, there are exceptions, of course. You can, like in Google scale, for example, when you have one company processing like tons of requests from all over the world. They have to think about physical resources because that's a place where optimizing a percent of CPU spend might get immense savings. But that's an exception. For most businesses, hardware is cheap and developers are expensive. And that's for Kotlin, that's our main philosophy. Like if we're not building a system language. We're not trying there for every percent of performance. We are optimizing for developer time. And if we can sacrifice 5% of runtime performance, but save a lot of time for developer, we'll gladly do it.
Yeah.
Well, that's kind of a Pythonic attitude as well, because Python is always trying to focus on developer time.
I would not agree. No.
Oh, you wouldn't?
I mean, I try writing more than 10,000 lines of code in Python and see how much time you'll spend trying to maintain it. No, it's not. Python does not scale to big code. No, you'll start wasting enormous amounts of resources.
What works well in the small doesn't work well in the large, and
yeah, I mean that's true. I mean, a lot of big systems have been built in Python, but it does you have to become better and better at guarding yourself.
Yeah.
So
I've heard a story related to this about TypeScript, and the origin of TypeScript was that Microsoft started building VS Code, and they got to, I don't remember what the number of lines of code it was of JavaScript, hundreds of thousands of lines of code, and they couldn't move forward anymore. Like their progress was just like the code base is, we can't evolve this code base because of lack of types, I think being one of the primary reasons. And so then they're like, okay, well, let's go create a new programming language on JavaScript that we can then have a code base that can evolve.
Yeah. So what's the hardest problem that you're struggling with in Kotlin right now?
Right now, lots of problems we're struggling with. We're constantly struggling with something. If from the development standpoint, we're writing new compiler, so we're basically changing the engine of a car while it's running at full speed. That's but that's a really cool project. I mean, that's the main reason for this project is compiler performance. Like the new compiler is the front end is 4 times faster, and the full pipeline will be 2 times faster than the old one. That's totally worth it. And while we're doing that, we're also cleaning lots of corners in the language design, because as you know, Kotlin is not this specific language that's doing a spec, and it's actually funny how I just today read uh, Alan Kay's interview in ACMQ, where he tells that he thinks it's a mistake to do a language based on a spec. Like you should use a compiler as as a thing that specifies your language. But anyway, so the Kotlin is like that. So Kotlin is not like Java where you have a spec and then implementation. In Kotlin compiler is a spec. We do have a spec for Kotlin, but the spec is there to help. It's not as a core reference. Is to help people understand what language does without reading the source code of compiler, because
it's like the compiler source code is the source of truth for what.
Yeah, the compiler is the source of truth, as language reference is there to help people understand it without having to read the source code of compiler. But so when you write the compiler, we're definitely running into a lot of cases where things
you find an ambiguity.
Or we find some strange behaviors in the old compiler that can't be explained, and so we're also cleaning up the design in those cases. We're making more orthogonal, cleaner, easier to implement, faster to implement, and that's where lots of interesting design issues come from. Just they're being discovered as we implement new compiler. And we're also trying to push language forward, gathering use cases from people and seeing what we can do. Contextual receivers, we're also, there's a big thread of trying to improve the support for statics in Kotlin and extensions on static extensions on classes. That's the most voted issue in language shaping right now. Adding ability to have static extensions on third-party classes. So that's things of that variety.
Yeah. Will Kotlin native ever support Windows native?
What's Windows native?
Well, in other words, right now Kotlin native for Windows is
LLVM based, and I think it does today. You can build Windows executables with Kotlin native today.
Can you? Oh, okay.
You can do it, and you can use all the.
You have to use the compiler. You have to use
Clang or
you something like that. Okay, that I think that's where I was thinking.
Yeah, okay. It uses LVL toolchain, but not Microsoft toolchain. But it does support all the Microsoft APIs, so you can build native Windows apps with full access all the Windows APIs natively and directly.
Okay.
So, a question maybe to wrap up is Kotlin in the Red-Monk language ratings is number 18, which it's pretty amazing to be in the top 20. I'm curious how you see, if you want Kotlin to be more used. I'm assuming yes, and if so, what are the ways that you think that Kotlin will grow in adoption?
So I mean, we have two short-term focuses for that and one long-term. So short-term things we focus on is JVM server-side, where we see lots of growth potential. There's still millions of developers who write server-side Java and not Kotlin, and there's really natural path for them to migrate to Kotlin. And so we're constantly studying this audience, seeing what we help them with. Where this compiler rewrite is actually is catering to this audience, because many people in this group, they say, "Oh, we love Kotlin, but it compiles too slow." So this compiler rewrite will significantly reduce, big impact there. We'll let more people adopt Kotlin without repercussions in their compiler.
This is an area where I see a lot of movement happening right now. There is a Reddit thread a couple months ago that was kind of asking the question about server-side Kotlin usage, and the number of people that were responding and say, I'm in a large enterprise, I'm working in financial services, I'm a Spring Boot Java developer, and all these people are like, we're going all Kotlin. And that story just keeps becoming more predominant, that more and more of those traditionally Java server-side enterprise companies a lot of financial services are going Kotlin, I think is indicative that there's something big happening.
We're seeing big growth for this space. I mean, last year we saw 40% growth on server side, and for server side that's a big number because it's really like there's a big systems that don't change fast, unlike mobile. Like our growth of mobile was like exponential. Like it increased orders of magnitude, in a year, but it's definitely won't repeat on server side because different nature. So 40% growth a year there is really good one, and we want that to repeat and to sustain this kind of growth on server side.
Well, our friend Bill went back before he became all Scala Zio guy. He was programming in Java, and they did a little hackathon week, and his was to try Kotlin, and he came away going, if it's just because it deals with nulls better, if it just because that's totally enough reason to switch over.
There's so many other reasons.
Chasing down null pointers was, and not having them happen was
that's a big reason. So for server side, we're not looking to add more feature. So we don't see any feature on the horizon that would make server-side developers shouldn't say, "Oh, I'll switch to Kotlin because of this feature." We don't see any. Our goal right now is to remove barriers. So we see we're preventing people like performance in compilation and working on those. So we think we have all the features to take over server-side. We just need to remove the remaining barriers that we have. Mm-hmm. That's it.
Well, the interoperability is so key because so many of these organizations have legacy Java, and they can't just go rewrite the thing. You're talking about like they can't just stop everything for years and go rewrite in a new language.
And it's really impressive. Well, because my first attempt at interoperability was with Scala, and the hoops that you had to jump through to make that work, I think most people would just be it'd just be too much work, whereas Kotlin just seamlessly drops in. I mean, really, the amount of effort that was put into that story was amazing, because it just drops in and works, and you don't even have to know.
Just start adding Kotlin files to your source code.
Exactly. And that's super impressive.
And it's not, it's at the price we still pay, in the sense that you'd be often when designing new features or fixing bugs, I mean, we spend lots of time just thinking about Java interoperability, how to make it better. There's lots of effort daily in the team goes into interoperability with Java. That's really conscious effort because that's the big core audience that we cater to. We want that for them for all to work really smoothly
and have that transition path. So I'm curious. One other thing. You said there's two things that your growth angles for Kotlin.
So the second one is multi-platform. So we see the interest in multi-platform really growing, and it's while this JVM serves the established market, it's not growing big. So we're just capturing parts of it, but the market itself not growing that fast. Here we see a big growing market where many people are discovering the benefits of sharing their code between Android and iOS
and their server
and server, exactly. And that's new market is growing. More and more people do this, and we are investing heavily to participate in that, to give a solution for people where they can share code, works on all platforms, write once all your business logic, and then you don't have to debug it twice or thrice. Just compile for different platforms using different application. So that's our second big investment that we're doing right now together with. And there is a third, more strategic thing, is that we really like to in the future to be able to tackle the JavaScript on the front end side. Well, we strongly believe that the fact that JavaScript dominates the front end is a big misfortune that our industry has. It's not something we'll be able to correct tomorrow or in a year, but that's something we think we'll be able to correct in years to come.
Is that through WebAssembly?
Yes, that's what we bet on. We bet on WebAssembly, and we work invest a lot of to make sure Kotlin works great.
This is like a longer term effort because
Yeah.
WebAssembly
Because
today
WebAssembly
has,
itself is evolving. Yes,
Mhm.
so we're working closely with vendors who do WebAssembly to make sure our efforts are aligned with how they evolve WebAssembly. So then, in a few years, one thing that's really important for us, because right now, if you look at state of the art WebAssembly that's in production right now, it's the WebAssembly that's in production is geared toward low-level languages, the system languages, right? Rust, C. It's not well suited for application languages with automatic memory management, etc. So for us, it's really important. One important piece of WebAssembly development is support for WebAssembly garbage collection in WebAssembly, and because it both gives us ability to directly compile high-level language like Kotlin to WebAssembly, and also gives us ability to seamlessly interrupt with the browser, because what we want people to be able to write web applications in Kotlin, and writing web application in Kotlin mean have interaction with all the DOM APIs that are also
you
automatic.
got to have the interop with JavaScript.
You have to interrupt, and it's not just interrupt. You have to, your memory manager has to understand that your Kotlin objects points to these JavaScript objects, and this JavaScript has this Kotlin listener. You have to, your memory manager has to be able to go through all these references to collect your garbage, and that means WebAssembly has to understand, has to expose these interfaces. And that's something that's not in production yet, that's in development. And we're doing our work based on the early prototypes that's currently being worked on.
That's exciting.
So I'm curious, how much of your time, it seems like you spend a bit of time doing stuff like this where you're kind of promoting and explaining Kotlin, versus how much time are you like heads down being an architect and working with developers actually rewriting the Kotlin compiler, for example?
So if you look at my day job, what I mostly do, like I have two hats. So I lead the project, so I have to make sure team works well. People know what to do. Have plans, etc. And I also lead language designer. So my second hat is I participate in design language. Everything else, promotion is not my primary job. We have a great marketing team in Kotlin and great team of developer advocates that go to conferences, promote Kotlin. We have a really experienced and professional team of compiler developers. These people, they really know their stuff. They really know how to write compilers. All these things, so that's. So I'm trying to leave, these things to professionals and not intervene as little as possible into their professional work.
Nice.
Well, that's a good note to end on. Thank you for your time. Thank you for sharing your wisdom and everything with us. We appreciate it.
Yes.
You're welcome.
Thanks for making Kotlin so awesome.
Thank you very much.